Good morning, students. Today we are going to discuss about module number 1, that is basic concepts. Here we are going to discuss about that concept of supermesh analysis and problems on supermesh analysis. So first of all, to discuss about that supermesh analysis, let us go through that concept of mesh analysis. In case of mesh analysis, the first step is we have to identify the number of meshes in the given circuit. So for example, if it is the circuit, in this circuit here I am identifying the two meshes. One is called as mesh 1 and one is called as mesh 2. In mesh 1 I am going to assume that mesh 1 current as I1 and mesh 2 current as I2. Now writing the KVL equations for these two meshes like mesh 1 and mesh 2. By solving those equations, here we are going to identify that loop currents with that loop currents, and we can find out that the voltage drop across each and every resistor for that respected resistors in the given circuit. In similar to mesh analysis, now we are going to discuss about that supermesh analysis. So we are going to apply that one more super technique called supermesh analysis from mesh analysis. First of all, let me the question why we have to apply the supermesh analysis. The question behind that why we have to approach that supermesh analysis technique instead of mesh analysis, because in this mesh analysis where we applied in the given circuit, there is no any current sources between the boundaries of the two loops. There is no any current source. For that case, it is easy to apply the mesh analysis. But if it is the case where there is a current source between the two loops or two meshes or at the boundaries of the two loops. For example, if you take this circuit as a reference, in this circuit there is a voltage source V and there is a resistances like R1, R2, R3, R4, R5. So all these resistors are connected and form as like a circuit which has been shown in this figure, and that too here for reference they are taken the three currents in the three meshes. For suppose if I am going to assume it as mesh 1, the current flowing in this mesh is assumed as I1. For suppose if we assume that this mesh as mesh 2 and the current flowing in this mesh as mesh 2 current is I2. For suppose if we are going to assume this mesh as mesh 3 and the current flowing in this mesh is I3. Now for these three meshes, if we are taken the references as the three currents like I1, I2 and I3, now if you closely look at this circuit having that mutual resistors. For example, R1 is the mutual resistor for mesh 1 and mesh 3. R2 is the mutual resistor for mesh 3 and mesh 2. Similarly, here there is a one current source which is located at the boundaries of the two meshes. One is mesh 1 and mesh 2. This is this small I. So whenever there is a current source between the boundaries of the two loops, but that time it is not possible to use the mesh analysis to simplify the circuit and to find out that unknown loop currents. So there, to overcome that difficulty, now we are going to approach a technique which is called a supermesh analysis as to overcome the difficulty. How to apply the supermesh analysis here? How we are going to apply the supermesh analysis to identify the solution means, here we have to write that a current equation, that is the differences of these two mesh currents. One is I1 and I2. In this I1 and I1 current is like the current source direction. So I can give the priority for I1. I can write it as equation I1 minus loop 1 current minus loop 2 current. I1 minus I2 is equal that current source I. Then one more current equation with respect to loop 1 current equation by applying Kirchhoff's voltage law. Here we get one current equation, and we have to apply that one more KVL in combination of loop 1 and loop 2 with this dotted line what I am showing in the given circuit. So in this way I want to apply a KVL in combination of mesh 1 and mesh 2, hence that current equation is called as super mesh equation. By solving those three equations we are going to find out the three unknown currents by applying this super mesh analysis technique. Now for better understand about this super mesh analysis topic, I am go through that a problem, that is find the current I naught in the circuit shown in figure. So if you look at this circuit very closely, there is a current I naught at here. This current I naught I want to find by applying the super mesh analysis, because it is not possible to use mesh analysis, because in this problem there is a 4 milliamperes current source which was located between the boundaries of this mesh and this mesh. So I want to apply the super mesh analysis technique at here. So let us, the first step is identify the loops. Here I am identifying that the loops as loop 1, loop 2 and loop 3. Arbitrarily I can select that the three loops, and I am going to assume the three loop currents as I1 in loop 1 in clockwise direction, in loop 2 in clockwise direction I2, in loop 3 also in clockwise direction, that is I3. So according to these three current directions we have to apply the KVL to write those equations of those meshes. And if you observe very closely here, for mesh 3 and mesh 2 there is a current source 4 milliamperes. It is not possible to apply the mesh analysis, where we have to apply the super mesh analysis technique. So if I want to apply the super mesh analysis technique here, I want to take the two meshes at a time, that is mesh 3 and mesh 2 as like this what I am showing the dotted line here. I want to apply the KVL in this way and I want to write the equation. Now for the given problem there is one more direct inspection method we have to apply, and we can identify that easily. The current flowing in loop 1, the current flowing in the loop 1 here, there is a current source 2 milliamperes. It is a self current source for loop 1. So I1 current is equal to 2 milliamperes. From direct inspection method we can identify that answer. Now by applying that super mesh analysis here, a 4 milliamperes is there between the boundaries of loop 3 and loop 2. So if you look according to that currents what I am already assumed like I3 and I2. So here I2 current direction is equal 4 milliamperes. So I want to give the priority for I2. So I want to write the current, I want to write the differences of these two mesh currents equations, that is I2 minus I3 is equal 4 milliamperes. This is that our first equation. Already we got I1 is equal 2 milliamperes. Now I2 minus I3 is equal 4 milliamperes, and again I want to apply the KVL in combination of loop 3 and loop 2. Now let us apply the KVL in combination of loop 2 and loop 3 and write the KVL equation. If I am going to write the combination of KVL equation with loop 3 and loop 2 or mesh 3 and mesh 2, the current equation is followed as 2 into 10 power 3 into I2 plus 2 into 10 power 3 into I2 minus I1 minus Vxy is equal 0. So now I am going to simplify this equation, that is 2 into 10 power 3 I2 plus 2 into 10 power 3 I2. Total it is 4 into 10 power 3 I2 and minus 2 into 10 power 3 I1, then minus Vxy is equal 0. Here I know that already that I1, I want to substitute that I1 wherever I have that I1 is equal 2 milliamperes. Then the simplified equation become as minus 6 plus 1 into 10 power 3 into I3 plus Vxy plus 1 into 10 power 3 into I3 minus I1 is equal 0. Now by simplifying these equations by using either Cramer's rule or direct inspection method, here we got that solutions as I2 is equal 10 by 3 milliamperes and I0 is equal I1 minus I2. How I wrote that I0 is equal I1 minus I2 here? If you look at the given circuit here, I0 I naught is nothing but the current what they given in the given problem. So I naught is located between the boundaries of mesh 1 current and mesh 2 current. So among these two currents, which current is like I naught current direction? That is I1. Therefore, I1 minus I2 is equal I naught. I1 minus I2 is equal I naught. So in connection to the I1 minus I2 is equal I naught, here I naught is equal I1 minus I2. I1 minus, here I1 minus I2. I1 minus I2 is equal I naught. From there I naught is equal I1 minus I2. Okay, here I1, already I know that I1 is equal 2 milliamperes and I2 is equal 10 by 3. If you do that LCM, I0 is equal minus 4 by 3 milliamperes. This is the way how to find the solution for the given circuit, especially how to apply that supermesh analysis as to overcome the difficulty when a current source which was located between the boundaries of the two meshes and to find the answer. Thank you.